Hi all. In the previous video we have learnt about binary classification using logistic regression, which is one of the simplest methods of machine learning. In this video we are going to take it further and learn how to do multi-class classification using logistic regression. So we call this multi-class logistic regression. So now there are three different ways of doing it. First we will discuss two of them which are based on binary classification, and then we will go to the third method, which is what is actually recommended for solving such problems. But before getting there, let's see how we can use the concept of binary classification to do multi-class logistic regression. So let's say instead of having just two classes, you have a problem where you have three classes. For example, it could be 4, it could be 5, but for the sake of simplicity, let's take a 3-class problem. So for example, you could have an email which you want to classify as spam, important or not important. Or you could have an image which you want to classify into, let's say, a dog or a cat or a mouse. So there could be many such possibilities. So now how do you use binary classification? The first and the simplest method of doing this is called the one versus all method, or it is also called the one versus rest method. So how does it work? So let's take the image classification problem for example, and let us denote this dog category as D, cat category as C, and the mouse category as M. So now this problem of 3-class classification can be converted into 3 binary classification problems. So what you can do is that using your data set, you can learn one hypothesis function which gives you the probability of classification between D versus and a composition of C and M. So here you put C and M in one category, call it the not dog category, and then learn this classification. Now you can learn another hypothesis function which tells you the classification between the cat and D, M. So now you put the dogs and the mouses in a same category and you learn how they are different from cats. And then you have the third function which is M versus D, C. So you put all the dogs and the cat images now in one category and learn how they are different from a mouse. And now how do you decide which category a particular image lies in? You take the maximum out of these three. So now your H is equal to max of H1, H2 and H3. So whichever of these three values is the highest, that will tell you which category a particular image lies in. So if you have k number of categories, you will have to do k such binary classification. So this is k number of binary classifications. So now this is the simple one versus all method where you can use binary classification to solve your multi-classification problem. There is another method which one can use for this multi-class classification problem, and that is called the one versus one method. So what do you do there? So there what you do is that you take each pair of categories and learn to do classification between them. So you have D versus C, you have C versus M, and you have D versus M. So here you will have KC2 number of binary classifications. So as compared to the one versus all method, here you will have to do more number of binary classification problem. And finally, how do you decide the category? So pick the maximum out of them. So then the predicted category is the one which has maximum predictions out of above KC2 binary predictions. So these are the two ways in which you can use binary classification for doing multi-class classification, but these problems have three primary issues. The first thing is that in the case of binary classification problem, we were able to predict not just the category but the probability of the given input belonging to a particular category. Now here that is not possible. So in these two methods, one versus rest and one versus one, we can only predict the category of a particular input, but we cannot exactly predict what is the probability. The second thing is that this one versus one in particular is computationally very expensive, because we need to do KC2 number of binary classification problems. So if your K is large, your KC2 will again be very, very large. In comparison, this is relatively cheaper, because here you only have to do K number of binary classifications. And the third important limitation is that here you have to do binary classifications to begin with. Ideally, we should have a method where you directly do multi-class classification, because there are higher chances of learning the actual distinguishing features between the three or more number of categories. Because here when you do a clubbing like this, then there are chances that you are not really learning the features of different categories very well. So now we will see a particular method where you can do multi-class classification directly without resorting to binary classification. So for that, what we are going to use is a very, very popular and commonly used technique in machine learning, what is called one-hot encoding. So now, since we have multiple classes, our output is now a vector. So in the binary classification problem, if you remember, the output was just a scalar. So here the output is going to be a vector. So let's say we have our 3 classification problem. So our y is a vector with 3 elements. So this denotes the first category, this denotes the second category, and this denotes the third category. And each of them can be either 0 or 1. So this can be 0 or 1, this can be 0 or 1, and this again can be 0 or 1. So if the first one is equal to 1, then that represents that it is a dog. If this is 1, this represents it's a cat, and if this is 1, then it represents a mouse. So for the output values of our given data set, only one of these will be 1 at a given time. So let's say our given output for a particular input is representing a dog, then the vector y will be 1 0 0. If it is representing a cat, then it will be 0 1 0, and if it is representing a mouse, it will be 0 0 1. So this is how our output data set looks like for the given data set. But now again, as you remember from the binary classification video, that when we are doing machine learning, it is not possible to make exact predictions, and that is because the given data set is often corrupted, it has noise. And so what we can predict is only the probability of the given input belonging to a particular category. So what we are going to predict is again a vector. So our h will again be a vector, h1, h2 and h3, and each of them will represent the probability of the input belonging to a particular category. So this h1 represents the probability of the output being equal to a dog given the input values and the model parameters. This represents the probability of the output being a cat given input and parameters, and this represents the probability of the output being a mouse given the input and the parameters. And obviously all these three probabilities must add to 1, because the given input has to lie in one of these three categories, and so these probabilities must all add up to 1, and individually all these must be between 0 and 1. So now let's see how do we do this. So again, like last time, we need two things. Firstly, we need the hypothesis function. So we need to write a mathematical expression for this h in terms of x and theta, and then we need a loss function or a cost function which we can minimize. So here for the hypothesis function, what we use is the softmax. So this is our hypothesis function. So now we define a quantity zk which is equal to e power theta 0 k plus x I transpose theta k. So here also you have an I. So this superscript k represents the category. So for each category we have these parameters, and this I represents the input data point. So I goes from 1 to n. So you have I going from 1 to up to n, and the k goes from 1 to 3 up to capital K. So we have capital N number of data points and capital K number of categories. So now if you have a 3 category problem, your k will be 1, 2 and 3. But here we are writing the term in general. So now using this, our hi for the kth category is going to be equal to zik divided by sum over k zik. Now this obviously, as we can see, satisfies our two requirements, which is that our all hi's k must be between 0 to 1, and for a given I, when we sum over k, this must sum to 1, and we can see that this function satisfies both these properties, and this is what is the softmax function. So this is our hypothesis that we are going to use for the multi-class classification. And now we need a cost function, so that is just a simple modification of the binary cross entropy. So in the multi-class case, we use what is called the categorical cross entropy function. So this is again a very simple formulation. So for the K class problem, we have the cost function is equal to again 1 by capital N summation over I is equal to 1 to capital N summation small k equal to 1 to capital K over minus yi k log of hi of k. So this is just a generalization of the binary cross entropy function. So in the binary case, you have two terms because your capital K is just equal to 2. But in the categorical case, you can have multiple classes. So you just take a sum over all the various possible values of K's which go from 1 to capital K. So that's all. Your problem is solved. You have defined the problem, you have defined the hypothesis function, and you have defined the loss function. So now your objective is that for a given data set, you choose the parameters theta which minimize your cost function. And how do you do that? You again do that using gradient descent. Because these problems do not have a closed form solution for the parameter values. And in the linear regression case, we also saw that even though the minimization problem has a closed form solution in the form of normal equation, but implementing that is a challenge when your data set is large. So what you do in practical cases is that even if you have a closed form solution available, you use gradient descent. And here you do not have a closed form solution, so then your obvious choice is to use gradient descent for your problem. So this is a theoretical description of multi-class logistic regression, but to really understand how this works, you need to write the code on your own. So again, in the description box, you will find a link which explains how the Python implementation of logistic regression works. So please do take a look, write your code, and deepen your understanding of logistic regression. So in the next videos, we are going to learn about more advanced techniques of machine learning. So till then, stay connected.